Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over Le Chatelier's principles practice problems. So we're going to look at some of these problems and we're going to try to figure out what Le Chatelier's principle is going to tell us is going to happen in each of these changes that we make. So I've got 8 practice problems, and so we're going to go through each of them, and I'm going to show you what to do. Now, before I go ahead and do this, I'd like you to just pause the video and see if you can fill in the rest of this table by yourself, and then restart the video and let's see how well you do. Okay, so problem number 1. So we're given N2 gas plus O2 gas is in equilibrium with 2 NO. So we have our 2 reactants, our 1 product, and they're in equilibrium. So what is our stressor? Our stressor is we're going to increase the concentration of N2. So remember, the first question we want to ask ourselves is what phase is N2 in? Is it a liquid solid or is it a gas aqueous, right? So if we go to here, we see N2 as a gas. So yes, there's going to be a change. So we got to figure that out. So what is N2, a reactant or a product? It is a reactant. So we're increasing a reactant. So let's write that in, increasing reactant. And so what happens to the reaction when you increase the concentration of the reactant, right? So according to Le Chatelier's principle, it's going to undo that stress. So if we're increasing the amount of a reactant, it's going to want to decrease that amount. And so in order to decrease this, the forward reaction, the forward is going to have to increase. So it's going to have to shift towards the right here. So it's going to shift towards the right, shift towards products. And so here our shift is going to have to be to the right. So it's going to create more products. So what's the changes? Once it reaches equilibrium again, what are they going to be the changes to our concentrations? Well, since we're making more product, the concentration of NO is going to have to increase. So concentration of NO increases. So that's going to be increased at the new equilibrium. And our oxygen is going to be used up because we're trying to take our reactants and make more products. So the reactants are going to decrease. So the amount of oxygen we had at equilibrium is going to decrease. So we could put that here. Concentration of oxygen is going to, that should be decrease, not increase. So the concentration of our oxygen is going to be lower than it was before. It's going to decrease at the new equilibrium point, right? So now what about nitrogen? This is where it gets a little tricky. We increased the nitrogen, so we had a lot before the equilibrium. So we threw some in there. We increased the amount of N2. Well, the equilibrium shifted towards the right to get rid of some of that N2. Did it get rid of all of what we added? No. So it's not going to get rid of all of it. It's going to get it's going to get rid of as much as we can, but it's not going to get rid of all of it. So in the end, at the new equilibrium, you're going to have an increase in the N2 than what you started with. So for N2, there's going to be a slight increase. So it's not going to go back to where it was. So there's going to be a slight increase in the N2 concentration at the new equilibrium. Okay, so that was problem number 1. What about question number 2? Here, we got a new reaction. So here we have H2 gas reacting with I2 gas, and that's going to form HI. So it's forming 2HI gas, so hydrogen iodide gas from hydrogen and iodine gases. Okay, so what's our stressor? We are increasing the concentration of HI. So our question again is, what phase is HI in? Is it liquid, solid, gas, aqueous? So we look here, HI is a gas. So once again, it is going to cause a change. So Le Chatelier's principle is going to apply to this. So where's HI? HI is a product. So in this case, we are increasing a product. So we're increasing a product. So what does Le Chatelier's principle say when we're increasing a product? So we're increasing on this side. So Le Chatelier's principle says we want to decrease, or we want to undo the increase of our HI. So how is the reaction going to decrease the amount? Well, it's got to shift this way. It's got to get rid of product and increase reactant, right? So it's going to shift towards the left. So it's going to shift left in order to get rid of the HI that I put in there, that I increased. So what's going to happen? Well, if this is going to be, if this is shifting to the left, this is going to decrease and these two are going to increase. So what's going to be the change at the new equilibrium? Well, both of these are going to increase because it's shifting this way, right? So the concentration of H2 is going to increase, and the concentration of I2 is also going to increase. What about HI? What is its new concentration at the new equilibrium? Is it going to be back to normal? No, it's not going to be back to where it was because we added some of this. It's not going to get rid of all of it. So in the end, the amount of HI we have is going to be slightly more than what we started with. So the concentration of HI is going to be slightly increased. So it's going to be slightly increased. Okay, so that's number 2. What about number 3? So number 3, our equation is we have carbon monoxide gas reacting with water gas, and that's going to form CO2 gas and H2 gas, and this is an equilibrium. So again, what is our stressor in this case? In this case, we are decreasing the concentration of H2. So again, the question we want to ask ourselves is, what is the phase of H2? Is it a gas? Is it aqueous? Or is it liquid solid? Okay, so here, H2. H2 is a product and it's a gas, so it will affect the equilibrium. So Le Chatelier's principle is going to apply. So this is a product, so we are decreasing product. Okay, so we're decreasing product. And again, what we said before, in this case, since we're decreasing product, Le Chatelier's principle says that the reaction is going to undo that decrease. So it's going to want to shift to increase product. So it's going to shift towards the right. So it's going to shift towards the right to create more of the H2 that I took away, right? And in the process, it's going to decrease the amount of CO and H2O, right? So what's going to happen? It's going to shift right to create more product to try to get it back up to where it was before. So what's going to happen? So at the end, when we have our new equilibrium, what are the changes to our reactants? Well, those reactants are going to go down. So the concentration of CO goes down. The concentration of H2O goes down. And remember, H2O here is a gas, so that's why we can say that it's going to go down. If it was a liquid, it would be no change, right? But in this case, it's a gas, so there will be a change to the concentration of H2O. So then what about our CO2? So since we're shifting towards the right, that means that we're going to increase the amount of CO2. We're building up more product. So CO2, the concentration of CO2 increases. Oops. Sorry about that. My light went out. All right, so we increase CO2. Now, what about H2O? We decrease the amount of H2O, and now that H2O concentration went back up, but it's not going to go back up all the way to the original point. So it's going to stop at a lower concentration than what it started with. So we're going to have a lower, it's going to be slightly lower than what we started with. So the concentration of H2 will be a slight decrease. So it's going to be a slight decrease compared to where it was before. Okay, number 4. Here we have two SO2 gas, sulfur dioxide gas reacting with oxygen gas, and that's going to be in equilibrium to the product of sulfur trioxide gas. So here's our balanced equation. Here's the equilibrium. And so what's the stressor? The stressor in this case is that we are increasing the total pressure. So we're increasing pressure. So what's going to happen? What do we look at? What's the question? Well, the question is what side or what is the number of moles of gas on each side of your equation, right? So we need to look at that. So right here, we see we have 2 moles of SO2 and we have 1 mole of O2. So we add those together and we have 3 moles. I don't know if you could read that. So we have 3 moles here and we have 2 moles here. So on this side we have 2 moles of gas. So now we know which side has more gas or more moles of gas, and we know that we're increasing the total pressure. So Le Chatelier's principle says that it's going to undo that. Well, it's going to have to decrease the pressure since we increased it. Well, how is it going to decrease pressure? Well, it's got to shift to the side that has less moles, less particles of gas. Less particles of gas means less pressure. So it's going to shift to the side that has fewer moles. So the product side has fewer moles, so it's going to shift towards the products. It's going to shift right. So it's going to shift right again. Okay, so that means that the SO2 is going to increase. So the concentration of SO3, did I say SO2? I meant SO3. So the concentration of SO3 is going to increase because it's shifting right towards the product. So this is going to increase. And this is going to decrease. So the SO2 concentration and O2 concentration are going to decrease. So SO2 concentration is going to decrease, and the O2 concentration is going to decrease as well. So there's no slight decreases here because we haven't really added or subtracted any reactant or product to this. So it's there's no slight decrease or increase in this situation. Okay, so what about number 5? So here again we have 3 oxygen, 3 moles of oxygen gas and 2 moles of ozone. O3 is ozone, so we have O3 and they're in equilibrium. And what's the stressor in this case? Here we are decreasing the total pressure. So again, the question you want to ask yourself in this situation is what number of moles are there on each side? What is the number of moles of the gases on each side of your equation? So this one is easy. Here we have 3 moles of O2. So we have 3 moles of gas here, and we have 2 moles of a gas here. So here we are decreasing pressure. So Le Chatelier's principle wants to increase that pressure back up. Is it going back to the original? No. but it's going to go back up. So it's going to increase it. Well, in order to increase the pressure, it's going to have to increase the particles of gas. And so it's going to have to shift towards the side that has more moles of gas. So it's going to shift towards the reactants in this case. So it's going to shift left. So the shift is going to go left. And so what's going to happen? That means that we're going to increase our reactant, oxygen, and we're going to decrease our product, ozone. So the concentration of oxygen is going to go up, and the concentration of ozone, O3, is going to go down. And so that is the change that we are going to see at equilibrium, the new equilibrium that is established. All right, number 6. What about number 6? So here we have H2O2 liquid in equilibrium with H2 gas and O2 gas. And so what is our stressor? We are going to increase H2O2. So increasing H2O2. So again, we're back to the same question we said before. So what is, in this case, we're increasing the amount of our reactant. So we're increasing reactant. And so the crucial question is, what phase is this reactant in? Is it a liquid, solid, gas, or aqueous? In this case, H2O2, hydrogen peroxide, is a liquid. So is that going to have any effect on our equilibrium? No. Liquids and solids don't affect the equilibrium. So if you change the amounts of those, Le Chatelier's principle is not going to apply, right? So we don't have to worry about it. So here, there's no shift. And therefore, here, there's no change in the amounts that we have. There's no change in the concentrations of what we have. So that's number 6. What about number 7? So here we have carbon monoxide gas reacting with hydrogen gas to give you CH3OH, which is methanol. So here we have a balanced equation in equilibrium. And so what's the stressor in this case? We're adding argon gas. So adding argon gas. So we're adding a gas, right, that could have effects on the pressure because we're adding a gas to our reaction mix. We have gases here. So that's going to increase the total pressure of our reaction vessel. But here we need to pay attention that, look, argon gas is an inert gas. It's a noble gas. It's not going to react with anything. So is it going to have an effect on the pressures of our other gases? Well, no, because of Dalton's law of partial pressures. Because the partial pressure of one gas, argon, will not affect the partial pressures of each of the other gases. So since this is an inert gas and doesn't react with anything, it's not going to change any of the amounts here. It's not going to change the pressures due to these in the reaction vessel. So the total pressure of these partial pressures stays the same. So no effect. So here we have, again, this is inert. This is inert gas. So no effect. No effect. And so here we're going to have no shift. And once again, no change to the concentrations or amounts of our substances. Okay. Last but not least, number 8, we have a combustion reaction. Here we have methane gas reacting with O2 gas. So we have CH4 gas reacting with O2 oxygen gas, and that's going to create CO2, carbon dioxide, and water vapor in the gas form plus heat, right? So you burn some methane gas and you get fire and you get heat production and light and all that. So here's our reaction. And our stressor in this case is we are going to increase the temperature of our reaction. So here we have a temperature change. So the question we need to ask ourselves is our reaction here endothermic or exothermic? So is it, which side is the heat on? Is it a product or a reactant? In this case, it's exothermic. It's releasing heat. We all know that combustion reactions release heat. So here, the heat is on the product side. So we can treat it like a product in the same way that we treated the change in N2 or the change in HI or the change in H2 here, right? So it's the same thing. So if we think of increasing temperature as increasing the amount of heat, right? What does that mean? That we're increasing product, right? How do you increase temperature? You got to put heat in there. So if you're putting heat in there, you're increasing the product, which is heat. And so Le Chatelier's principle wants to undo that. It's going to shift to get rid of heat. It's going to shift to get rid of product. That means it's going to have to shift towards the reactants. So methane and oxygen, those are going to increase, right? So here we should write down heat is a product. Okay? Heat is a product. And so what's the shift? It's going to shift towards reactant because we're increasing the heat, the product. It's going to shift towards reactant. It's going to shift to the left. So big L, shift to the left. And so what's going to happen to our concentrations of things at the new equilibrium? Well, we're going to increase CH4 and O2. So the concentration of CH4 is going to increase, and the concentration of O2 is going to increase as well. And so what's going to happen to these here? Well, the products are going to decrease. So our concentration of CO2 and H2O decreases. Okay. And so here we have CO2 that's going to decrease, and our H2O is also going to decrease. Okay, and so that's how you can figure out whether or not a reaction is going to shift left or right based on your reaction equation and based on what the stressor is and how to apply Le Chatelier's principle. Okay, so one of the things I want to point out that I'm going to get to more into when I do my next video, when I talk about the equilibrium constant, is the only time your equilibrium constant is changed is when you change temperature. And the reason for that is because I haven't added anything here. I haven't changed the concentration here by adding something. And so the shift here is changing the concentrations that are related to your equilibrium constant. The rest of these are not going to be affecting your equilibrium constant. But more on that in the next video. So if you're confused by that, don't worry. Go to my next video and I'll explain it all to you. But if you like this video, please, by all means, share this video, like this video, hit that like button, and also make sure you subscribe to my channel, hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think and ask me any questions. I would love to hear from you. Thanks for joining me. Have a great day.